Hey again everybody, in this tutorial we're looking at pulleys, trying to calculate the mechanical advantages of pulleys and things. The first thing you need to know about pulleys is that there are two kinds. There's either a fixed pulley or a movable pulley. If you have a fixed pulley, then you have an automatic mechanical advantage of 1. And this is what we consider a fixed pulley. Anything that is attached to, say, a ceiling, a roof, a wall, anything, and it's not allowed to move up or down. So if this were a rope hanging off of this pulley and this were a 200-pound weight, if I had to lift this 200-pound weight, I'd have to be putting a little bit more pressure than 200 pounds on this rope in tension to be able to pull it. So whatever you have in your as your load or your force of resistance, your force of effort has to be at least that large. So that's MA of 1. On the other hand, this type of pulley over here is a moving pulley. This pulley is in between the load and the force of effort. So we have to look at that, and we have an automatic known mechanical advantage of 2. So now we have an MA, a mechanical advantage of 2. That means that if we're lifting 200 pounds here, then we're lifting half the load. You can take 200 and divide it by 2 and you get 100 pounds. So the amount of force we have to put on this rope right here is 100 pounds. Another way of saying that is the roof or whatever we're attaching the pulley to is holding half the weight, and we're holding half the weight. So we have a mechanical advantage of 2. So in order to be able to lift 200 pounds, you would prefer to have a movable pulley in your system as opposed to a fixed pulley in your system. So let's say we're going to add another pulley to the system. So for this pulley system, we have 2 movable pulleys. So for this pulley, we have an MA of 2, and also for this pulley, we have an MA of 2. So if we have more than one pulley in the system, what we have to do is multiply the mechanical advantages together. Now we can say 2 times 2 is 4, and we can divide 200 pounds by 4. Now our force of effort is only 50 pounds on this system. So you can say that what's happening here is 200 pounds is being divided by this strand and that strand. So that makes the 200 pounds. 100 pounds goes to the ceiling, the other 100 pounds goes to this pulley. So now this is 100 pounds here. Now this one has 2 strands. It has a strand here, a strand there. So if this is 100 pounds, then we want to take 50 pounds and give it to the ceiling. 50 pounds we're having to pull. So this would be a much better mechanical advantage, and you can keep adding pulleys to your system, and you just have to multiply the mechanical advantage of 2 times 2 times 2 if you had another pulley, and you would keep splitting the amount of weight that you would have to pull in half. So it's a very efficient way of moving things and being able to lift things, and that's how we use block and tackles and those kinds of things. We'll look at a block and tackle next. Here's another example of a pulley problem. We have a block and tackle. This block and tackle is fixed to something, and so this one has a mechanical advantage of 1. This block and tackle is also, or this pulley is also attached to that pulley, so that makes this a mechanical advantage of 1 pulley. But this one here will move, and this one here will be pulled along. So we have a mechanical advantage of 2 times 2 times 1 times 1, or 4. So we have the same mechanical advantage as we had in the last exercise. So we take 200 pounds, we divide it by 4, we get 50 pounds. So this block and tackle will move a 200-pound weight by pulling on this rope 50 pounds. So we have basically a, what is that, a 4 to 1 ratio. Mechanical advantage of 4 to 1 in this block and tackle example. So I hope this has helped you a little bit with pulleys, and we'll do a mechanical advantage on a pulley exercise later when we get to sprockets and gears.